Hello everyone. Today's my theory of computations topic is about types of grammars, and it's also known as Tom Chomsky's classification of grammars. We're gonna discuss of the types of grammars and its functions, how to identify the grammar. So here the types of grammars. So according to Chomsky's, there are four types of grammars: type 0, type 1, and type 2, and type 3. So there are four types of grammars. The following table is as shown below. Like there are four types of grammars: type 0, type 1, type 2, and type 3. So we're going to see what type of grammar accepted, and the language accepted, and what kind of the machine is used to identify the language by particular machine, so that it can be identify the language. So in type 0 we're going to see the type 0. So in type 0 it is an unrestricted grammar. So type 0 is a unrestricted grammar. So in this type 0 the language is accepted as uh, recursively enumerable language, and automata is Turing machine. So the language accepted is recursively enumerable language. So it is uh, it is recognized by the Turing machine. So in type 1 is a context sensitive grammar. The language used is context sensitive language. It is recognized by the linear bounded automata. So linear bounded automata is used to recognize the particular language. So what kind of languages it is used? So the automata is used to the mm, identify the languages used in grammar. So as third one is type 2 grammar, where in type 2 grammar the grammar is accepted by context free grammar, and the language is accepted by context free language. So in this, the automata used in type 2 is uh, push down automata, is nothing but PDA. In short form it is called as PDA. Push down automata is used to recognize the context free language. So next is the last one is type 3 type 3 No, type 3. The grammar accepted is regular grammar, and the language used is regular language, and the automata used is DF and NFA. DF is nothing but deterministic automata, and non-deterministic finite automata. So we're gonna discuss in detail about these types of grammars in the upcoming slides. So now we're gonna first see about the type 0 grammars. We're gonna see that the definitions of type 0 grammar. Type 0 grammars generate recursively enumerable languages. The productions has no restrictions. So in type 0 grammars there is no restrictions. The production have no restriction. They are any phase structure grammar, including all formal grammars. So they can be in any grammar. I mean like any phase. This is what it says as it is unrestrictable. There is no restriction. It can be used anywhere in the phase. So the word used is unrestricted. They generate all language. They generate the language that are recognized by a tuning machine. As I told earlier, the language is recognized by a Turing machine automata. The production can be in the form of alpha gives to B beta, where A is a string of terminals. String of terminals is nothing but a small alphabets. Non-terminal is also known as variables with at least one non-terminal, and alpha cannot be null. So beta is a string of terminals and non-terminals. So for type 0 grammars, these specified conditions should satisfy. So if it is satisfied, then it is supposed to be called as type 0 grammar. For example, the productions alpha cannot be null. Alpha cannot be null. This condition should be satisfied, because this in type 0 there is no alpha cannot be null, and second is not A is a string of terminals. So in A have to be string of terminals, that is small letters. Non-terminal is nothing but variable, at least should have a one non-terminal. in non-terminal or variable, at least have one non-terminal variable. So we see the example, this S is A, C variable and A terminal and B. So as you see, at least one non-terminal is there in this given example, like BC gives to AC comma variable B. Next is CD, CB gives to CB. So in this you can see the examples that is satisfied by the type 0 grammar. Uh, Next is type 1 grammar. In type 1 grammar, generate context sensitive languages. The production must be in the form of A alpha beta gives to A y b, where A summation n non-terminal and A comma beta y summation tun strings of terminals and non-terminals. The strings A and beta may be empty, but y must be non-empty. The rules are S summation is allowed if S does not appear on the right side of many languages. The language generated by these grammars are recognized by the linear bounded automation. For example, AB gives to AB variable B C. So these are the conditions given by the type 1 grammar. If if the given conditions is satisfied, then it is supposed to be called as type 1 grammar. And type 2 grammar. In type 2 grammar, type 2 grammar generate context free languages. The production must be in the form of A comma beta, where A summation n non-terminal and beta summation t union n star string of terminals and non-terminals. These languages generated by these grammars are recognized and by non-deterministic custom automata. For example, S equals x a, x is equal to b a. So where in beta summation t equals n, there should be one variable in this type 2 grammar, and in type 0 also there is unrestricted, so that is also used in this type 2 grammar, where a is not terminal to variable. So this is also have to consider in the type 2 grammar. The last one we're going to see is type 3 grammar. In type 3 grammar, generate the regular languages. Type 3 grammars must have single non-terminal on the left hand side and the right hand side, consisting of a single terminal or single terminal followed by a single non-terminal. The production must be in the form of x goes to a or x goes to a beta, where x and beta summation n non-terminal and a summation t terminal. The rule S is some I is allowed if S does not appear on the right side of any row. For example, there should be two cases where you can identify the type 3 grammar is occurred, where S needs to be summation and the production value should be x comma terminal, or x gives to terminal plus beta. So if these two conditions satisfied, then the type 3 grammar is recognized by the particular this type 3 grammar is used is recognized by a DF and an NFA, deterministic finite automata and non-deterministic finite automata is used to recognize it, the type 3 grammar. So if these examples are going to satisfy, then the type 3 grammar is used. So this is all about the type of grammars and the examples and how to recognize the grammars. This is all about the topic. Yeah, that's it. Thank you.